In this question, there is an electric field pointing upward. Pointing upward, we have an electric field. And we have a charged particle being levitated. So let's say you have a charged particle and being levitated, meaning it is just floating in air. So the charge is 10 microcoulombs and the electric field value is this. What is the mass of this particle? So things to think about. What are the forces on this particle? So remember that we have F equals QE, where F and E are vectors. And what this means is that if Q is positive, so if Q is positive, then F and E are in the same direction. It has to be because these are vectors. So if Q is negative, then F and E are in opposite directions or 100 degrees to each other. So let's just go back to our problem. So we have E, and then we have a charge which is positively charged, which means F and E are in the same direction. So on this particle, we have our force, our electric force upwards. And if this is being levitated, what does that mean? That means something else has to balance that out. So what can that be? That can be the weight of the particle. So if the force because of the electric field is upward, and then that can balance the weight of this object, then this particle would levitate in air. So we know that this F is equal to QE. So now looking at the y direction, what we have is QE, which is equal to mg. So let's just look at the magnitudes of this. So Q is 10 times 10 to the negative 6th coulombs. And then E, we have 8.5 times 10 to the 5th newtons per coulombs. This is equal to mass times 9.81 meters per second squared. So this gives us M is equal to, we are going to divide both sides by 9.81. So we have 8.5 10 to the 5th divided by 9.81, and that gives us about 0.86 kilograms. So in questions where an object is levitated, you equal the force because of the electric field to the weight of the object.